Okay, linear approximation is kind of weird because you're like, well, why would you approximate something and not just plug something in? Definitely things with roots, that you can't get exact values. This was used a lot. And what you're going to see to approximate a value, okay, this linear approximation, how you approximate it is what I always tell students is you take what you want, and this is going to equal what you know plus the known change, the rate, right? That's the derivative. And then I call this the actual gap, okay, from the value that you know to what you want to actually get. So if we have a problem like this, says use linear approximation to approximate these two values using this function. Well, I can see by looking at my formula that f of a would just be, and I'm going to do this, here at x equals 1. F of a would just be f of 1. And so to be able to do this approximation then is I would do f of 1 plus f prime of 1 and then some value x minus 1. All right, hopefully the first thing your eye looks right there and says, oh, I'm going to have to find a derivative. So maybe I should do that first. So let's do that first. So the derivative, I'm going to take this function and rewrite it as x plus 3 to the negative 1/2 power. Okay, it'll just make it easier to not have to use a quotient rule, that I can use the chain rule. So now to take the derivative, I bring my power down, negative 1/2, I leave the inside alone, and then I subtract 1. So negative 1/2 minus 1, which would be 2 over 2, which of course would make this negative 1/2 x plus 3 to the negative 3/2. And then to plug in over here, then I simply will just plug in 1. So in this case, I have negative 1/2, 1 plus 3 to the negative 3/2. And what I did is I rewrote this as negative 1 over 2, 1 plus 3 to the 3/2. And then finally, so negative 1 over 2. Remember that the power is what's on the inside, and the numerator to the power is what's on the inside. So in other words, this is 1 plus 3, which is 4 cubed, but then it's square root. That's what this 3/2 means. And so I would get negative 1, 4 times 4 times 4, and then square root it. Okay, so 4 times 4 times 4, which gives me 64. I square root it, I get 8, and then I multiply it by that 2, and that's how I'm getting this value. So now I have everything over here I need. F of 1, well, I guess I didn't actually do that yet. F of 1 is plugging 1 in. So 1 over the square root of 1 plus 3 into the original function. Then plus what I did over here, negative 1 over 16, and then x minus 1. All right, so let's scroll this down a little bit, give me a little bit more room. And then, of course, 1 over the square root of 4 would be 1/2. And then typically what you want to do is go ahead and distribute this piece, okay? This makes it easier plugging things in. And so I'm going to have minus x over 16, and then the negative in the negative will be a plus 1 over 16, which I can rewrite the 1/2 as 8 over 16. I'm just getting a common denominator, x over 16 plus 1 over 16. So in other words, this is going to give me negative x over 16 plus 9 over 16. And now from here, I can just simply plug in my values that they wanted me to estimate into this linear approximation, this function. And when I did it, I got these values right here, 0.49875 for my answer. And that's it. That's how to use linear approximation.